Okay, these are the instructions for the variation and distribution assignment. I am going to go over a few of the definitions because when we get to the actual assignment, it's a writing assignment, and you're going to have a word bank with these definitions that you have to use. And if you don't fully understand the words, or if you've kind of forgotten and you just need a refresher, this is super important because you can't complete the assignment if you don't truly know what the definitions are. So the first one, this is actually kind of a new word. We've only used it a few times. This word is called distribution. It is the number of individuals with each trait in a population. So if you're looking on the right-hand side, we are looking at a chart, right? A histogram, similar to a bar graph. And so when we're looking at that chart, we can see that these weird looking animals, they're fake animals. They're called australopes, and we're actually looking at them today. But they have lined up according to their skin color. And so we can see on the left-hand side at level 1 right here, those are some bright blue australopes, right? Some bright blue animals. And then on the very right-hand side at level 10, we have a couple of yellow australopes. And then right here in the middle, level 5, level 6, we only have 1 or 2 green australopes. And so what they have done in this example is they have distributed the animals or the australopes based on their color. So another example we could use is if we were trying to figure out the hair color in our classroom, then we could designate each corner of the classroom as a hair color. And we could put everybody with black hair in one corner, everybody with brown hair in another corner, everybody with blonde hair in one corner, and then everybody with red hair in another corner. And that would show distribution, right? And so the next one we're going to look at, you guys already know this word, variation, any difference in traits between individual organisms. You can see in the example, all of those are, what kind of dogs are those? I don't even remember. I think they're labs, right? If I'm wrong, I'm sorry. I'm pretty sure they're labs. They are labs, but there's different colors of labs. You can see there's brown, there's a white blondish color, there's a black color. That's variation, right? And then we already know this word as well, non-adaptive trait, a trait that makes it less likely that an individual will survive in a specific environment. If we have a non-adaptive trait, that's going to hurt us. And chances are we're going to end up dying before we can reproduce and pass on that trait. And then, of course, we have the opposite of non-adaptive trait, an adaptive trait, also known as adaptation, which we spent a lot of time talking about. So an adaptive trait or an adaptation is a trait that makes it more likely that an individual will survive in a specific environment. So in this example right here, we can see we're using the polar bear as an example. The polar bear blends in with the ice, right? And so it makes it an even better predator because its prey isn't going to be able to spot it coming. And then the last one, this is just a refresher. When we say population, we mean a group of the same type of organism living in the same area. So you can see in this example right here, we have a group of giraffes. They're the same type of organism, the same species, right? Giraffes can all reproduce with one another, and they're living in the same area. Okay, so before we look at our chart, we again are looking at fake animals today. And the first animal we're looking at is called an australope. And as you can see, these fictional australopes are different colors. There's a yellow, there's some blues, there's some greens. And so we're going to look at that a little bit closer today. Okay, so you have your chart. And before you begin, I don't want you to feel overwhelmed, especially if you're group B and I'm not there. You have a chart. Let's always look at the title of the chart first. So it says australope color variation. We know there's going to be a variety of colors in the australopes, and that's what the chart is going to be representing today. And then if we come over here, right, on the y-axis, we can see this is the number of australopes. It goes all the way from 0 to 90. And then down here, this is the color level of the australopes. So we've got a level 1 over here, which is going to be blue. And then it goes all the way up to a level 10, which is going to be yellow. And then, of course, this 5 and 6 is going to be somewhat of a mixture of that green. So we just have a wide variation of color that these australopes could possibly be. And then we notice that there's two different colored bars. The blue bars represent the very first generation of australopes, right? The very beginning. And then the red bar represents the 50th generation, right? So some time has passed between the first and the 50th generation. And so at the bottom, it gives you a little bit more information. So that starting population, the first generation, it says many color traits with high variation. Okay, so we can definitely see that, right? Almost every single color is represented at the starting population, the first generation. And we have high variation. We have about 10 blue. We have about 15 level 2 blues. We have about 20 level 4 like bluish greens, and we've just got a lot of variation. We even have a couple of yellow way down here. And so we've got all of these color traits, all of this variation in the starting population. And then towards the ending population, right, again, the 50th generation, all yellow, right? These are all yellow australopes at this point, or level 7. And there's no variation anymore. There isn't a lot of variety because they're all the exact same color. And what we've noticed is the environment has changed. So the surface color slowly changes to a yellow surface color. So before it was a bluish green, and now it's completely yellow. The environment is yellow, and the environment also includes predators. There are predators that chase the australopes. So from this information alone, and from this information from the graph, we're going to go to the next slide, and it says, based on the information from the previous slide, how can you explain why the distribution of traits changed in this population? And you have to use these words right here: adaptive trait, distribution, environment, non-adaptive trait, and variation. So if we go back, we can see there has definitely been a change over time. Okay, so first of all, what is the adaptive trait? Well, we can see that the adaptive trait over time is going to be that yellow coloring, right? The non-adaptive traits, if we come over here to this one, we can see the non-adaptive traits are obviously going to be the blues and the greens. That's not very beneficial anymore. We can see that the distribution and the variation have shifted, right? The distribution was once pretty even, right? Evenly distributed. There were some blues, some greens, some yellows, but now it's all changed, and now the distribution is just straight yellow, right? And same with the variation. Variation has gone down as well. The variation is now just all straight yellow. So why has this happened? Well, if we're looking at the environment, because the environment changed to a yellow surface color, right? And it includes predators. Those predators started going after the australopes. And what's going to be easier to see? A yellow australope in a yellow environment, or a blue and green australope in a yellow environment? Those predators went after the blue and the green australopes, and the yellow ones were able to survive and pass down their yellow traits. And so after 50 generations, this is why it looks like this. Okay, so you're going to answer this question, right? Use these words right here. And then you're going to go on to the next one. And you're going to do the same thing, but this time it's changed to fur. So now we're looking at australope fur. And we can see now that there are two charts, right? So at the beginning of this one, there is some low fur level traits with medium variation. The ending population, medium fur level traits with medium variation. And then the environment changed to a cold temperature. So we can see based on the chart, right? Here's our first generation. The red is our 50th generation, and there has definitely been a shift because over here in the first generation, we can see most of the Australopes had some low fur, right? And then on the right-hand side, on the 50th generation, it moves up to higher fur levels. Well, why is that? Look at the environment change, okay? And so you're doing this, you're answering the exact same question for these two graphs, right? And then you're also going to do the same thing for this last one. And this last one is looking at thorn palms. This is, again, this is a fictional plant, right? This is not a real plant. And we're looking at water storage, and you can see the examples. If we're saying, hey, that has low water storage, right, it's going to be very thin. And if it has high water storage, it's going to be a little bit thicker because it's holding a lot of water. And in real life, we do have plants that do store water. This is an adaptive trait, right? We could think about cacti. A cactus is able to hold and store a lot of water because it's in a dry area, right? It doesn't rain a lot in the desert, so these cacti have to be able to hold water inside. And so again, it's the same thing. We've got our graph. We're looking at our graph. We're looking and reading the title, and we're looking and reading the titles of the axes, right? The y-axis, the x-axis. This is the number of thorn palms. This is the water storage level, with number 1 being low water storage and number 10 being high water storage. And we're doing the exact same thing. Read the starting population information, read the ending population, and read how the environment has changed. And you're answering the same question. I know this is going to be a little bit challenging today, especially because I'm not there. But I want you to just slow down and take your time. This is not something that you can rush through because reading all of these charts is difficult and it's challenging and it's going to take some practice. So don't stress too much about it, but try to get this finished. And then when I get back, we will talk about this a little bit more.